All right, today I'm going to be going over the STIC grant for the cone penetration training and peer exchange. My name is Ryan Snook. I'm the Chief Geotechnical Engineer here at the Bureau of Bridges and Structures. So a little bit of background here. MDOT is implementing the Everyday Accounts Initiative 5, the Advanced Geotechnical Methods in Exploration, or AGAME. The first STIC grant was used to purchase the cone penetration equipment in 2019, and we started using that CPT equipment in 2020. You can see here, this is the equipment for it. The STIC was used to purchase this piece of equipment here with the auger, with the rods for that. MDOT purchased the Bobcat that's used to power the hydraulics and the power for that equipment with that STIC grant for the S4 push system as well. So with CPT, since this is a lightweight rig here, we have to anchor the system here with anchors in order to resist the pushing force with that. You can see we're anchored and we're pushing. What we're pushing here is the piezo cone. These come in a variety of different shapes or sizes, but the more heavier duty is the 15-centimeter piezo cone. So what that measures is the tip resistance, sleeve resistance, and here between the two is a porous stone, which measures the pore water pressure via transducer here. You can see it should be a video here. Hopefully that's playing for everyone. But we're pushing this down into the soil at 2 centimeters per second, which is the ASTM requirement for CPT. And that provides a continuous measurement of the tip and sleeve and pore water pressures. You can see here we're adding another section of rod. There's a wire that connects from the computer to the cone at the very tip of it. So you got to make sure everything's attached and pushing. See, we're just getting ready to start advancing that section here as well. This will be showing that this is pushing here, so we're keeping track of the inclination of it. We got to make sure it's staying within vertical as much as possible. If we hit a cobble or a boulder, then it throws it off and then invalidates the test. You can also see here we're measuring the tip, sleeve pressure, and the pore water pressure, and it's giving an indication of what's called the soil behavior type. And down here you can see the depth of it. So these are some examples that we've collected so far. This is 96 and East Beltline. This is a wide variety of clays and sands. There's generally the more tip resistance is sands, and the lower tip resistance is clays in general. Another good use of it, we just demonstrated here, is US 31 over County Drain 102. We got very low resistance of the tip here. So we're in organic soils or peat at that point. And then once we hit the bottom of that peat layer, then we get into native sands. So we'll be able to identify exactly where the bottom of that of the peat layer is. This also gives very good indication of the groundwater measurements that lines up with the stream, the elevation of that as well. Another site we've used it at is 94 under Barrett. This is in downtown Detroit. You can see this is a very typical profile for Detroit, where you got more desiccated crust on top of it, and then we start getting into more soft clay deposits here. We're actually able to pick up a sand layer here, which is very beneficial from when we're doing settlement calculations. We're looking at drainage paths for it. This is something that we may or may not be able to pick up with traditional SPT sampling. Since SPT sampling, we're collecting a 1.5-foot sample every 5 feet versus a CPT push, which gives a continuous soil profile at that point. To date, we've used it about 32 sites so far. There are many ways of using and interpreting the CPT data, and MDOT and MDOT consultants don't have much experience using the CPT data. So we identified this as a need for some more training for CPT use in Michigan. With that, we need to bring in an expert on CPT data collection and its use. We need to provide training to MDOT staff as well as geotechnical consultants. We work for MDOT and also for local agencies as well, so we'll be able to use that experience on both areas. And we want to have an exchange between MDOT and geotech consultants on their use and experience of CPT in Michigan. So the question is who to bring in. After talking with FHWA, CPT expert with the most experience is Dr. Paul Main with the Georgia Institute of Technology. He's an international expert on CPT use, and he's authored many papers on CPT. He's actually one of the authors of the FHWA Geotechnical Engineering Circular 5, Evaluation of Soil and Rock Properties, and he's also been awarded the Geotech Institute GeoLegend in 2016, as well as Carl Tazag Election in 2023, some of the 2 highest honors for geotechnical engineers. So he's a definitely a recognized expert with that. And here he is. The peer exchange took place on June 14th and 15th at the MDOT Construction Technology Building. 34 people attended the training, roughly half MDOT, half consultants. And we also provided a demonstration of the CPT equipment that we have at MDOT. You can see here's a picture of the training. Very well attended, a lot of engagement as well. And we have our demonstration outside as well. You can see that this is Aaron Poyce. He's showing our CPT probe, showing the demonstration of it as well. And this is the course content that we went over. There's a lot of information that was shared and a lot of knowledge that we're still processing as well. There's just a tremendous amount. Some of the results of the peer exchange are it's suitable for a wide variety of soil conditions, except where there's shallow rock or there's numerous cobbles and boulders. It's very well suited for delineating poor soil conditions, such as peat, marl, and very soft clay. CPT also provides a continuous profile, identifies small sand lenses layers that may be missed with traditional sampling. And the groundwater levels from both unconfined and confined aquifers can be identified and measured. From the peer exchange part of it and talking with other consultants, there is one other CPT rig in Michigan. It's owned by Meteco Drilling, and it was purchased just over a year ago. We have another consultant that works regionally and retrofitted one of their rigs in Ohio to be able to push CPT. And the other consultants have started to use CPT on other projects, but it's usually subcontract out to out-of-state contractors. The general consensus is that CPT is beneficial for use on projects. Some of the challenges noted from the exchange are the CPT provides a soil behavior type, not a soil classification. So we need to look at the difference between those soil behavior type and a classification, especially when it comes to contractual issues, when we're getting to potentially differing site condition claims. We also need to look at the soil behavior type. Classification tends to lump peat, marl, and very soft clay into the same soil behavior type. This is a shortcoming of it, and further research is needed in this area. And we've also noted that the shear strength derived from CPT correlations tends to overestimate the shear strength at lower shear strengths. So this is also an area in further need research. You can see a demonstration here. This is the areas that we have some soft clay and organic soils, and it's not quite matching up with where we'd like it to be at. So there's some different correlations out there that need to evaluate and see what is the best way of doing it for Michigan. When it comes to shear strengths, we've had some reasonably good correlations between traditional unconfined strengths or triaxial shears or beam shears at higher strengths, but they tend to overestimate at the lower end of it. So we're in the process of evaluating that aspect as well. So with that, further research is needed and evaluation of correlations to Michigan soils. And this research is currently under contract with the University of Michigan. So we're actively trying to implement CPT in Michigan and trying to improve it for Michigan soils. Any questions at this point?
This is Dan DeGraff. I got there's a lot of move as well in the vibration monitoring type rollers and things to be able to map full areas of projects as opposed to a specific single core location. How will this help us calibrate those devices or make use of those, or will they work together?
The CPT, it can be used for identifying areas, like more areas. So hopefully we could use it to further refine the limits of it potentially. But it's not a direct impact from one to the other. Generally found we can push it about 5 times faster with the CPT than we can with traditional auger borings. So we should be able to get more data points to be able to help further refine this.
Okay, yeah, as the technology for mapping subgrades improves and some of these automated devices that you can place on the surface, you still need to kind of correlate to what's real down below. And it looks like this could help with that, I would think. So you could get in there and get a few CPT ready locations and then map it and have a pretty good feel for what you really do have underneath your entire pavement structure.
Ryan, this is Rachel. Where all does MDOT look to use this CPT technology in the future?
We're looking at using it for obviously bridges, for like overhead signs, strain poles, potentially pavement applications as well. But we're still evaluating what's the best use of it at this point. But we got to make sure we're considering the limitations of it as well. We can't push it into hard pan or rock, so it's not appropriate in all locations. But there's definitely locations where and uses for it that look like they're well suited for.
Thank you.
Yeah, it looked like it was giving you a clear indication of, like, if you had an overburden of peat over top of more stable soil below, you could kind of get that depth determined more precisely than if you're taking a sample every 5 feet. So that continuous data looks helpful if you're trying to refine a design down and get the sense of how much material you got to remove or what you got to drive a pile down to. It seems like there's a lot of good information there with that continuous profile all the way down. So you're getting a lot more precise stuff. Is that going to save cost on foundations, do you think, if you have more precise locations of different lenses or sandy soils underneath the overburden?
Yeah, there's potential for that as well. If we can get more precise data on it, more locations, we should be able to help further refine, trying to identify what the soil conditions are at a site.
Okay. And does it have application for scour calculations? Is it related to, when we have we're trying to figure out how far down a large flood event would wash out soils around a bridge if a huge flood occurred? Would this help us understand where consolidated, unconsolidated soils are and how far down that washout might occur?
Not presently. I know there's different technologies out there that are in the works, but I'm not aware of using CPT in that regard at this point.
Okay. Seems like an interesting application. It might be helpful, but might not too. So just more advanced research there. Well, good to hear you had a good peer exchange, and got Dr. Paul May from Georgia to come up and learn from a real national or international expert on the topic. I think that'll help advance the use of this technology here in Michigan. And good to hear your research projects progressing and trying to get correlations for some of the specific soils we have here in Michigan. It does seem like in a state where we got a lot of glacial till, it's a very good tool. We don't have the bedrock and things like that other states have, so it looks like a good tool. Other questions? Does anybody else have any other questions for Ryan? All right. Well, thanks so much, Ryan, and wish you the best with your implementation of this new technology and the research project you got going. Anything else you wanted to mention before you take off?
Nope, not at this point. I just appreciate the support in this initiative, and we do appreciate the training that was provided with this. So thank you.
Yeah, thank you. Good to see you using the funds in a good way. This is a great example of the State Transportation Innovation Council grants that we can provide and bring forward a new technology here in Michigan, advance it a little bit farther. So thanks everyone on the council here for that input and all, and making that go.